Hey math fans, Test 9 Lesson 2. Get your swords ready and let's go. So today we're going to review how to write ratios in words, we're going to identify pattern rules, and we're going to solve problems with a number line. Let's start off with a quick review of writing ratio in words. So here we have some cars and trucks. I have 1, 2, 3, 4, 5, 6 cars to 1, 2, 3, 4 trucks, and there's 3 ways to write a ratio of that. First, I can do a comparison. So I'm doing cars to trucks. There's 6 cars and 4 trucks, so I can write it like this, 6 to 4. I can also write my ratio as a fraction, 6 over 4. And of course, when the denominator is smaller than the numerator, we call that an improper fraction. And last, our objective for today is to write it in words. So I can also write 6 cars to 4 trucks. All 3 of those mean the same thing. You're pretty familiar with ratio by now, so you probably are not shocked by that information, but it's just a quick review. So let's move on and talk about identifying pattern rules. Meet the magic number machine. You put a number into the machine, it applies an algebraic equation and spits out the answer. We want to figure out what the equation is. So here we have an example. Someone put in a 1 and a 7 came out. Put in a 2 and a 14 came out, a 5 and a 35, a 10 and a 70. So I'm going to start with the 1, that's always easiest. 1 plus 6 would give me 7. Let's try that for the next rule. 2 plus 6 would give me 8, so that can't be right. What else could I do to 1 to get to 7? Well, I could do times 7. 1 times 7 is 7. 2 times 7 is 14. 5 times 7 is 35. 10 times 7 is 70. I've found my answer. Yay me. So, to write the pattern rule, there's a couple ways I could do it. The simplest way is to just write the rule and say multiply by 7. So that works fine. I can also use an equation and write it as an equation. My in number times 7 equals my out number. Or I can replace in and out with letters to create an algebraic expression. So if I assign the letter m to represent the in numbers and the letter n to represent the out numbers, I would write this as 7m equals n. Remember, that's the same as saying 7 times m equals n. 7m and 7 times m mean the same thing. So pause the video here and see if you can figure out what is the pattern rule. I have 1 to 12, 2 to 24, 5 to 60, and 10 to 120. So looking at 1 times 12 is 12, so let's see if that works for the next one. 2 times 12 is 24, 5 times 12 is 60, 10 times 12 is 120, easy peasy. And again, 3 ways I can write that. I could just say the rule is multiply by 12. I could say in times 12 equals out, or I can say 12n equals m. I like this one. It's shorter, less writing. This one's a little bit trickier, so pause the video here, give it a try, see if you can figure out the pattern rule, and when you come back, I will have the answer for you. So this one starts with a 0, which is kind of nice because we can see that obviously it's going to go up by 4. So the only thing I can really do to 0 to get to 4 is add 4. So I should have 2 plus 4 equals 6, but I don't. That tells me that I must have done something to the 0 before I put in the 4. My equation is probably going to end with plus 4 because, like I said, that's the only thing I can do to 0 to get to 4. But anything times 0 is going to equal 0. So I'm betting that there's a multiplication in here too. It'll be in times something plus 4. Let's test that. So if I start with 8 and I take away the 4, I'm going to do that for all of them. Take away 4. Now let's see if I can find a relationship between 2 and 4. 2 plus 2 or 2 times 2. 5 times 2 or plus 2. And 10 times 2 or plus 2. Can't be plus 2 because 0 plus 2 would equal 2. So that doesn't work. So it must be times. That means that my equation is going to be 2m plus 4 equals n, or my rule will be multiply by 2 and add 4. So when you see something like this, it's really just a little bit of guess and check with some detective work to see how it all fits together. And pretty easy objective for our third one. We're going to solve problems with a number line. When you have a number line, you just need to remember that your negative numbers are on the left of 0 and your positive numbers are on the right of 0. And they're going to go up they're going to go away from 0 in either direction. So this would be 1, this would be 2, this would be 3, and so on. And this way I would have -1, -2, -3, and so on. So they start at 0, and they just kind of branch out in either direction. What we're going to be looking at today is if I gave you a clue, how would you find out what number I was talking about? So for example, if I asked you to start at 0, go left 2, and then go right 3, what number are you at? You are at number 1. If I asked you to start at 3, go left 5, 1, 2, 3, 4, 5, right 1, left 2, and right 3, you would be at 0. So basically all we're doing here is making sure that we realize that when you have a number line, your positive numbers go this way, your negative numbers go this way. They branch out from the middle like that. So when I'm faced with a question like this, what integer would be 5 to the left of -8, I know I just need to make a number line. The question says to the left, so I'm not going to worry about what's on the right of 8. I'm going to worry about what's on the left. If I did look at what's to the right, I know it would be getting closer to 0. So this way I'm going to go further from 0. -9, -10, -11, -12, -13, -14. Let's see if I've gone far enough. I need to go 5, so I'll start here and bounce my ball. 1, 2, 3, 4, 5. -13 would be the answer. Hopefully that makes sense. If it doesn't, you can always rewind and watch it again. 3 review questions for you today. Write the ratio in 3 different ways. That means as a comparison, as a fraction, and in words. Write the rule to match this function table. This is called a function table. It is not called a magical monster number machine table. So you're going to write the rule to match it. And what number would be 3 right of -6 on a number line? Have a good night. See you tomorrow.